First, I use the top much like I would on Earth, and it works about the same until it bounces off the floor and starts to float. The top does not touch the floor as it spins, so there's less friction than on Earth. For this reason, the top spins much longer and remains stable. This gyroscopic stability definitely works. Next, I release the top in the air and it turns in a stable manner, moving in any direction that I push it without changing its axis of spin. Conservation of angular momentum keeps the top's axis pointed in the same direction. Notice what happens when I leave the handle on. Now the top transfers some of its angular momentum or spin to the handle. When the handle and the top drift apart, they are both spinning and move in opposite directions to conserve linear momentum. In this experiment, I tape a bolt onto the rim of the top's disc to see how this affects the top's spin. On Earth, gravity acting on the unbalanced weight of the bolt would cause the top to fall over quickly. Here for a few seconds, it can be seen that pushing the top near its end causes a change in the direction of its spin axis. An unbalanced torque produces a change in angular momentum. So I added a second bolt and look for a difference. This time you can see a wobble in the top, especially when it's spinning slowly. The wobble is not nearly as dramatic as I thought it would be. Let's try it one more time, and the effect is still not dramatic. But with its long spin, the top is a great toy for space and reminds us of many spinning satellites we launched.